Hi everyone, this is Ankit from EcoSikho, and I'm back with another video on affine transformation. In this video, we'll be talking about rotations about the origin. If you haven't checked out the last video, then do check it out. In that video, we talked about what is an affine transformation and what do we mean by translations. We discussed in detail about how to do a translation. And in this short video, we'll be talking about rotations about the origin. So quickly jump into it. Let's say I have been given a unit circle. We know what is a unit circle. A unit circle is a circle with a radius of 1 units. And let's say I have a coordinate that looks like this, which is 1 comma 0. Or I can represent it in the form of a vector, which is 1 comma 0. I want to do a rotation anti-clockwise about the origin by 90 degrees or by pi by 2 in terms of radian. So I will reach somewhere around here, which in this simple example would be 0 comma 1. So after doing a rotation about the origin in an anti-clockwise direction through pi by 2, I have made a vector which was 1 0 into a vector which is 0 comma 1. And this transformation is what is known as rotation about the origin. So I started off with a matrix X that resembled 1 comma 0, and I ended up at a matrix X dash that looks like 0 comma 1. So I am multiplying this vector X with a rotation matrix A that gives me this. And that's the objective of this video. We want to find out what is this rotation matrix A. So let me define what is a rotation. So in simple terms, rotation means it turns every vector around the origin 0 comma 0 by some angle. For example, a pi by 2 rotation sends 1 comma 0 to 0 comma 1. So what we can conclude, under rotation, the length of the vector remains same, only the direction changes. Rotation is also known as spin. So if whenever we are getting a question like do the spin, we can say that we have to find out the rotation. So like we discussed in the previous video, whenever we want to convert a vector x into something x dash, we pre-multiply this x with a matrix A and we add a vector which is B. This pre-multiplication matrix A is also known as transformation matrix. And this vector B was also known as translation matrix. But in this video, we are only going to talk about rotation. We are not going to talk about translation. So for us in this video, the vector B will become 0, 0. So effectively, we are left with AX is equals to X dash. So let's try to find out what is A. What is the transformation A, transformation matrix A looks like here, which is cos theta minus sine theta, cos theta. Now this A is my transformation matrix, or this A is also known as rotation matrix. Okay. What's so special about A? If I try to find out the determinant of A, I will be getting cos theta times cos theta minus sine theta times sine theta, which leaves me with cos square theta plus sine square theta, which is equals to 1. So what we can conclude here, we can conclude that whenever we are dealing with a rotation matrix, whenever we are dealing with the rotation about the origin, the determinant of the rotation matrix will always be equal to 1. And whenever we are dealing with a rotation about the origin, the rotation matrix looks like this. The pattern for the rotation matrix looks like this. So these are the two things we need to keep in mind. So we need to keep in mind how does the rotation matrix looks like. We need to keep in mind the determinant of rotation matrix should always be equals to +1. And we need to keep in mind how does the pattern of rotation matrix looks like. Now you might be wondering, sir, what is this theta? Theta is the angle the vector makes about the origin. For example, in the previous one that I was doing over here, the value of theta was pi by 2. So let us quickly do a question. The question is, I have to find the transformation matrix A for a rotation about the origin clockwise through 5 pi by 6. That means I have a vector that is being moved 5 pi by 6 degrees in the clockwise direction, and I'll end up at a new vector. I need to find out what should I pre-multiply my existing vector with so that I arrive at a new vector which is exactly 5 pi by 6 in the clockwise direction about the origin. So one thing we should know that whenever we are saying that there is a clockwise rotation through 5 pi by 6, that also indicates that there is an anti-clockwise rotation of minus 5 pi by 6. We have to be careful. Whenever we are dealing with rotations about the origin, it only takes into account the anti-clockwise direction and not the clockwise direction. So we need to reverse it. So next thing, what I need to do is that I need to find out the transformation matrix or the rotation matrix A. The rotation matrix A looks like this: cos theta minus sine theta, and cos theta. And over here, what is the value of theta? The value for theta over here is minus 5 pi by 6. So putting the value here, so I need to find out cos of minus 5 pi by 6 minus sine of minus 5 pi by 6, sine of minus 5 pi by 6, and cos of minus 5 pi by 6. So using our graphic calculator, we can find out the value for cos minus 5 by 6 and sine minus 5 pi by 6. So using our calculator, we got the value of minus root 3 pi by 2, minus 1 by 2, 1 by 2, and minus root 3 by 2. This is the value for the transformation matrix. So what we are trying to find out, we had a vector x. We are pre-multiplying this vector x with the transformation matrix A that we just found out to arrive at x dash. Okay. If I have to put the entire thing in the form of figure as well, let's try to make this in the form of figure. So whenever I'll try to draw a figure, I'll always start off with a unit circle. The unit circle will always have a radius of 1 unit. Let's say this is my vector here, which is 1, comma 0. According to question, I am going on a clockwise rotation through 5 pi by 6. Now do not get confused whenever I try to go in the question clockwise and while trying to find out the matrix A, I do the anti-clockwise. But while drawing the diagram, I have to respect the question. I have to respect the information given in the question. So in the diagram, I will be doing a clockwise direction of 5 pi by 6. So this was my matrix. This was my vector A. After doing 5 pi by 6 in the clockwise, I am reaching somewhere around here. Now this is my 5 pi by 6. What can we say about this coordinate? We can say that this coordinate is minus root 3 by 2 and minus 1 by 2. Minus root 3 by 2 and minus 1 by 2. So that's how the diagram for this question looks like. If you have a confusion, sir, how did we arrive at this point? So what you can do that in this equation, you can take your x as 1 comma 0 and you will arrive at a x dash. So yeah, that's how we do this question. Now let's say I have been given this question. I need to find the nature of transformation and I've been given x dash looks like minus 5x plus 12y divided by 13 and y dash looks like minus 12x minus 5y divided by 13. So this x dash and y dash can be written as x dash is equals to minus 5x divided by 13 plus 12y divided by 13. And this y dash can be written as minus 12x divided by 13 and minus 5y divided by 13. Now, in the form of equation, I can write that my x dash looks like minus 5 by 13, 12 by 13, minus 12 by 13, and minus 5 by 13. And this is being multiplied with x and y. This x dash can be written as x dash and y dash. So I have been given a classic question where I can see that my transformation matrix looks like this. And I need to find out the nature of this matrix. So first off, I'll start off by finding out the value of determinant of this matrix A. So if I try to find out the value of determinant of matrix A, that will be minus 5 by 13 into minus 5 by 13 minus of 12 by 13 into minus 12 by 13. So while doing so, I'll be getting 25 by 169 plus 144 by 169, which is 169 upon 169. That gives me 1. Okay. And also, the matrix A looks in the form of A minus B, B, and A. So based on this two information, that is the value of the matrix being equal to 1 and the pattern for the matrix that looks like this, I can conclude that the matrix A here is indeed a rotation matrix. What next? Next, I can clearly see that the value for cos theta will be equals to this. So I can say that cos theta is equals to minus 5 by 13 and sine theta will be equals to minus 12 by 13. So using this two information, I can say that theta lies in the third quadrant. Since cos is also negative, sine is also negative, I can conclude that theta lies in the third quadrant. So next, what I can do, I need to find out the value for theta, which will be cos inverse 5 by 13. So using our graphic calculator, we can say that the value for theta is equals to minus 1.97 radian. So what we can say that there is a clockwise rotation about the origin by 1.97 radian. So I hope this clears your doubt about rotation about the origin. Please let me know in the comment section if you want some more numericals on this chapter. And in the next video, I'll see you with reflections.